Doo-doo. Yes. No, I haven't yet. I got to. Oh, okay, okay. I'll do it after I got class. Morning. But, all right. So no, this isn't the weather out there this morning. It's gray out there, but this is a picture from the fall when there were boats in the Northwest Arm. But if you're not from Halifax, or you're not here, the Northwest Arm, it's sort of parallel to the harbor, the back harbor. And this spot is around the Armdale Yacht Club, which is at the head of the Arm, close to the Armdale roundabout. And there's a little park that's in between the roundabout and the yacht club. And this is looking down the Arm, sort of a gray, foggy morning. And that's a duck or maybe a heron that was landing at that point. We get lots of birds around that area. Anyway, nice and peaceful start. We've got a very wild day coming up in Halifax tomorrow. 10, 15 centimeters of snow in the morning and up to 50 millimeters of rain in the afternoon. I get drowned. Anyway, let's get on with today. And I got a few updates before I get into my slides. With assignment 1, grades should be posted. They should all be marked by now. And that there were a few students that missed the assignment, and they've been in touch with me. They had technical issues, and that have emailed me the assignment. But there are a few others I haven't heard from. And if you're on this morning's class, you should follow up with me after class as to what might have gone wrong there. If not, I may well be following up during the week with you. I pick on people that don't get some of the stuff done. Same thing goes for the quiz. There are a few folks that didn't seem to do the quiz, and trying to find out what's going on there. With the assignment, a few students, their grades aren't what they would have hoped for. In my other class, I had a couple of students accidentally did the questions to assignment 1, to the fall assignment and not the winter one. So there are a variety of little problems we've had crop up. And I'll be working through with them on how to address some of it. A few have emailed me because of disappointment with their grade. What I started doing last term with my students is giving them the option to do a revise and resubmit. So if you did quite poorly on the assignment, and they're worth a fair bit, they're 8 points, and to reclaim some of those points, I'm giving them the option to revise the assignment, resubmit it to me, I'll grade it, and I'll average the grades between the original one and the revised one. And it's sort of like giving you back 50% of the points you may have lost. That help you along the way. I've already posted the solutions to the assignment, so you can go and look at them and see where you went wrong. And just don't do a copy and paste of my answer into your assignment. I had some students did that last term. I want you to think through and do it yourself so that you understand really what's going on. The other thing that's posted is a thing I'm trying out this term because we're using different technology and we're sort of in a different time with online classes. That you'll see with the solutions from the last fall, at the suggestion of a student last term, I created video solutions so that you could see how I did the operations within the spreadsheet. And so I've done that again with the solutions to your assignment 1, and I'll do that with future assignments if students find that it's actually helpful. The last term's class asked for additional how-to videos on a variety of different things. So that I can prepare those sorts of things if you find them to be a useful aid. I'd appreciate someone giving me some feedback as to whether or not they actually are helpful or not. But anyway, what's next? Um, remember, you've got a test coming up on Friday, test number 2. It'll probably be more difficult than test number 1. And it's not because it's intentional that we're going to give you nasty questions, but the material is more difficult. Quiz 4, I expect the grades, I haven't looked at them, but I expect they're lower than what we had on quizzes 1 and 2. And it's the nature of the questions. Excel questions tend to get harder to do. And your test number 2 is going to have a variety of Excel questions like the quizzes look like. So watch out for it. I still expect the grades to be fairly good. The grades so far have been very, very high. I expect at the end of the term the grades will generally be very high. And I'm not expecting any, hopefully, particularly low grades. If you got a particularly low grades because you didn't do assignments or tests or something. But if you did the activities, your overall grade should be at least passing, if not A's and B's. There'll probably be a lot of them. But the material does get more challenging as we're moving forward. So don't be stressed if you start to see your grades are slipping. You're starting from, slipping from a 90 or a 95 down to an 80 isn't the end of the world. Um, Assignment 2, I should have it out this week, and you'll see more on it as we get into it, but it's, again, very Excel heavy assignment. And I think that's it to give you in terms of updates. But if you got questions, concerns, that you'd like to have other practice stuff, I'd like to give you practice tests. And the trouble is that multiple choice questions are really hard to make up. If you many other instructors that use multiple choice, the questions come out of a test bank in their textbook. They didn't make them up. Someone else had them, and they could give you a sample test that way. We don't have such a thing here. So any quiz questions you've got, the ones that are in the text or the ones in your tests, are ones that I've got to make up. And it's hard making up different ones. And so I'm struggling to get your test ready for this week in getting a fair balance of questions in it. So I don't have sample ones for you to practice on. I'm sorry about that. That with the assignments, I've got old assignments that I can post. With your tests, no, I do have old tests, but even some of those I'm using to give me ideas for ones to put on your test. So I don't have a big pool of them to recycle. Maybe in another couple of years, after doing the course a couple of times, I will have that. But right now, I don't. I'm sorry. But the questions will be similar to the quiz as much as possible. And I think that's it. So, oh yeah, so there's the answer to that. I won't post a sample test because I can't make up enough questions. Um, and I've been trying to get the other instructors to help me making up questions, and they're struggling too. It's difficult, unless they're stupid questions. But good ones are hard to make up. Oh, and by the way, I posted a discussion for week 5, and um, a lot of the stuff we're getting into at the moment has to do with looking at patterns. And so when you're looking at patterns and generalizing, you're generally looking at correlations and cause and effect. And so if you see a pattern, you're going to try to generalize and make conclusions that A causes B. So the one I posed for week 5 is more asking you to go back and not look at alternate explanations for a pattern, but how do you get the data? And uh, you probably see in the media, uh, there are regular reports that keep coming out about our diet. And it seems that everything that we enjoy eating or drinking is bad for us. That someone's come up with a study that says that if you eat such and such, more than once or twice a week, or something of that nature, then your risk of such and such a disease goes up. And they don't talk about ones that have positive health outcomes. They're generally negative health outcomes. Or if it's positive health outcomes, it's things I don't want to do. And it's very discouraging. But think about, how do you do the research? How did they do the study? And I think in many of these instances, what I see in the media, they don't give me a lot of detail. I'd have questions about how they did the study. Think about how you collect the data. Is this an observational study or an experiment? But it's an experiment. How do they control things? How do they control what you eat? It's observational. How can you control for other factors about it? And they say, I'd be very careful on that uh, type of issue. I want you to think about, if you were going to do a study on whether or not eating hamburgers is good or bad for you, how would you carry that type of research out? And is it the type of burger, the number of burgers you eat, what's in the hamburger? That can you actually do that as a proper experiment? If not, if it's more of an observational study, are there other factors that may end up coming into play to explain any outcomes that you've got? So this is getting back to the very beginning of the CRISP cycle, where you may have stated the problem, that how do you do the data collection? This is the data understanding thing. And in fact, with dietary research, it's incredibly hard to do a good study. And so most studies probably have significant flaws to them. Um, Maybe the ones being done today are better than the ones that were done in the past. The ones done in the past were generally had a lot of serious design problems to the study, so that you could come up with multiple conclusions from the same data. Um, so give it some thought. So last class, I introduced you to pivot tables. They're one of my favorite tools, and they're great for showing patterns, generally between two variables. And we start out by putting them in a table, and we have different rows to the table and different columns to the table. And so how do you choose rows and columns? And then you summarize something in the middle. So how do you format those summary measures? And we may have some garbage in there, so we should be filtering things out. Maybe some of the groups don't belong in there, or distraction. Delete those. Maybe there's too many categories, so compress it, group them together. Maybe the categories need to be in order to make more sense to you. So the most important things at the top or at the bottom, and least important is at the other end. Or maybe they're ordinal, like from being very satisfied to neutral to satisfied, very unsatisfied. And it's important to have them in the appropriate order to be able to understand them. So, but there were two cautions there. One is that any numbers that you've got, we were looking more at averages, and the averages are not perfect. They're just based upon a sample. If I collected new data, I'd get slightly different averages. So if it was average salary, maybe that average salary could be off by $3,000. So it shouldn't be 50. Maybe it's as low as 47 or as high as 53, but it's definitely not 60. And if I had one group with an average of 49 and another one with an average of 58, I'd say they're probably different. But if I had one group with an average of 49 and the other with an average of 51, I'd say, I'm not sure. So if the difference isn't too big, don't read too much into it. If it's really big, maybe you're going to look deeper. But you may find that the difference is because you've got tiny samples. And if you've got tiny samples, there's generally a lot of error in your estimates. And so bigger samples are better. But often when we're slicing and rearranging our data, we end up with little groups. And that can be a distraction to us. So be careful on that end. But some of these issues are going to come up again in today's class. Because today I'm going to look a little bit at numeric variables, but my main focus is on categorical ones, of looking at a variable like gender, male, female, versus a variable like program, arts, business, science. And so they're two different categorical type variables. Whereas last class, we were focused on measuring salary and averages. Now I'm going to look at percentages more. And it can be more complicated than looking at averages. So first off, summarizing things, particularly when most of what I'll be doing today is counting things. Even with numeric variables, I'm going to be counting things. When I'm counting them and I put it into a table, we call it a frequency distribution. Frequency is how many, what count fits into different categories. And they can be categorical variables, like how many males, how many females, or how many arts, business, or science, that we took numerical variables and made them categorical, I did, when I classified salary expectations as being very low, low, middle, high, very high, and unrealistic. And so they're sort of ordinal categories I created. Others we sort of did by grouping values. When we made a histogram, we took numeric data, interval or ratio data, and we formed groups and then counted how many fit into each of the groups between 10,000 and 20, 20 and 30, 30 and 40. Those were groups, and what was the frequency? But the tools we used were really clumsy in doing that. But we can do it within a pivot table, and the chart, like the histogram, can be a pivot chart. So let's see, how do we do that? The way we're going to do it is by grouping things and so on. We're going to look at the data set we had last time. I've reposted the data file, so where we're starting, because we've done many things to it. So I'm going to start out with a variable, and I'll move back and forth like before between Excel and PowerPoint. If I was to build a simple frequency table of how many students are concerned, or their level of concern, about finding a job when they graduate, and there are different categories here, different types of responses. If I did it, I'm going to get this simple frequency table, and I can make a simple chart with it. So let me get into Excel. So here I've got a pivot table. I'm going to count things. Generally, I use ID as the variable I count, and I'm going to change its settings to count. Okay, and let me make it bigger so I can see it. Whoops, excuse me. Not what I want to do. Okay, so what I want to look at is their concern about finding a job. So I take any job and I put it down here. There we go. So there are different values here, and I could make it. I showed you at the end of last class how to make a chart. So if I click on my table here, up above, I've got different tools, pivot table tools, analyze and design. I'm going to pick analyze, and I'm going to pick pivot chart, and I get a picture, and I'll take this one. The standard picture is just this column chart. And let me get a little bit smaller, and let's see if I can move it down a little bit here so I can see my table and most of my chart at the same time. Let me take this out just so I can make it a little bit bigger. Problems I run into with this is some of the stuff is junk, not sure, not applicable. So I should probably start cleaning it up by getting rid of the categories I don't want. So tidy things up. We want our visuals in particular, particularly charts, to be as clean and tidy as possible. We would look at this and see, well, they're not sequenced in the right order. I want to go from one extreme to the other. So let me move this guy up beginning. So I go move, I'll move it up to the beginning, and I'll move this guy up to beginning. There, now it goes not concerned, somewhat unconcerned, neutral, somewhat concerned, very concerned. So this is a tidier sequencing, and I can look across my picture here and see from low to high. Interpreting numbers is awkward. What does 101 mean, or 162, or 221? So normally I'd want to go and change this to percentages. This is a frequency table or a frequency distribution. Most of the time we want relative frequency distributions. So I could go over here to count of ID, up to value field settings, change these things. Today I'll just show you a shortcut. I could right click on a number and it has summarize values. I've got that by count. I want to show values as percentage of column total. So this is the quick shortcut. And the other is I don't like decimals. So I'm going to change my number format. It's percentage. I'm going to get rid of the decimals in it because I find it's distracting. I don't need all that detail. And so here's a better chart, better table. I don't know if it's telling me anything at all. Maybe there's sort of a trough in the middle here. And some might think, well, I've got a cluster of students that are over here that aren't worried, and I got a cluster over here that are worried, very worried, and then some people in the middle. Maybe I have two groups. Maybe I should look and see who's very concerned. Can I look at their program or their gender or some background information? Or those that aren't really concerned? I'm surprised. I'd think you'd be worried about getting a job, pay off that student loan. That who are these students? Are they of a, can I group them together? Is there some profile that fits them? This is a relative frequency distribution for a categorical variable. And we'll be looking at this a fair bit today. What if it's a numeric variable? So let me go through my slides here. I think that this is what I did. Yeah, there it is all cleaned up. And the one I had here, I left the decimals in there, but it's clutter. It's unnecessary detail. And maybe there are two types of responses. If I was looking at a histogram, which is a column chart, the categories are for numeric variable. So what happens if I put salary as my variable on the left? So let me go back here. Take any job away from here. And let me look down here, find salary, put it there. I don't know how well you can see this picture, but it's a silly looking picture. It's a whole bunch of little spikes all over the place, and they're not very tall. Most of them are below 5%. And if I look at my table even, I've got a whole bunch of values with zeros. I'll show you why. If I go in here and change my number format, remember I got rid of the decimals. Let's put at least one of them back in for you. See, they're little tiny numbers, 0.1%, 0.4%. This is probably one student. That might be 3 or 4 students. So since they're such tiny numbers, they barely show up here. When we summarize numeric data, we put the values into groups. So we've already seen a function to do grouping. We grab a group of values and we ask it group. What if I go and grab a value and just one of them and click and say group? Well, what am I going to group 2000 with? If you do it, you get a little table. It's very tiny on my screen to see, so it's probably very tiny for you to see. It says auto grouping, starting at a value, ending at a value, and with certain increments. Maybe I'm going to start at 20,000, go up to 120,000. This is what we did with the histogram. And I'll go in increments of 10,000. Now I have to have the same increment. I can't have some groups wide and some skinny. So they all got to be the same size. But that's, we said when grouping data, group your data in such a way that it compresses it into a modest number of groups. As much as possible, have them the same size. And that's what we're doing. We're using nice numbers, following all of those principles. Click OK. Boom, I've got a histogram. It formed a group under 20,000, 20 to 30, 30 to 40, and all the way up, and over 120. Now, I may have told it to get, I only want it from 20 to 120, but it actually gives me the ones that are below and the ones that are above at the end. I can hide those if I want. So I don't want to look at them. Whoops, excuse me. Click on everybody and click on this one. Okay. And there I get my histogram. I'll leave that in there. If you wanted to look like a proper histogram, we said you should take away the gaps. So you can do that if you want. Click on any one of the bars, right click, can format the data series. Gap width over here, make it a 0. And there I've got the histogram. And this is the histogram, should look like the histogram we had last week. Or before last week, can't remember. And over here, it's got all the relative frequencies. So it's already scaled it. The histogram function gives just a frequency. So this one here, I can scale it if I want relative frequencies. So it adds up to 100%. So it's a neat, slick way of doing it. And it's easier than using the histogram function. I can say I've trimmed out the ones I didn't want. Remember, I couldn't filter things out with the histogram function. I had to keep everything unless I did a filter, copied the data to a new place, then did it. And one of the things that I wanted to be able to do was compare programs, arts, business, science. So let's do that. Let's take program, drag it to the columns, or the legend it has here. Oops. Might not be able to see that. Very busy. There's a bunch of values I really don't want. I don't want invalid, not applicable. I can get rid of them. And from here, these are percentages. I can see here's arts, it's the blue. Orange is business. Good. And the gray is science. And so it's telling me that art students have relatively low expectations of salaries at graduation. Science students have very high expectations, and business students are somewhere in the middle. And I've done this super quick and easy, so I can do all of the filtering. I can compare groups, all kinds of different types of comparisons I can do far easier in my pivot table and pivot chart. And remember along the way, whoops, excuse me, go back here. These are all percentages. So this is all of the art students adding to 100%, business to 100%, science to 100%. Having it as percentage of column total is really important here because I want to compare arts to business to science and how the pattern changes across the three. And moment, I'm doing it as percentage of column total. Again, I go back here, click on this thing, and I'm going to go to show values as, it said percentage of column totals. If I just did no calculation, I'd find I've got, at the moment, 630 values. 248 art students, 271 business, 111 science, and looking at these numbers and trying to get a sense of scale. That look at my picture that I've got at the moment. Same pattern, arts, business. Look at science. It's low everywhere. I can't get a sense of its shape because it's squished, because there are not that many science students. There are only 113 science students. So the columns are smaller, not because science students don't expect certain things to happen, but because I just have fewer of them. The scale I'm using is critically important. If I look at this 10 for business here and this 10 for science here, they're very different because this is 10 out of 271. This is 10 out of 111. I can't compare them. Look at 80 to 90,000. I've got 13 art students, 13 science students. So that's that was over here. I think, where is it? I want a 13. I'm looking at, what's the group? 80 to 89. Doesn't look right here. Oh, no. Oh, here it is. Hard to tell because I've taken away gaps. So it's left some gaps in and I'm not reading it in the right order. It's this column here, that blue one, and that gray one, both the same height. But those are two very, very different cases here that I'm going to cheat here. I'm going to put some gap width back in here. Got harder for me without, I'd like to look at all these clusters together. So I want to look at this cluster of 80 to 89. They do look to be about the same, but that's my scale. If I went and changed it to show values as percentage of column total and looked at it, then I'm back here at the 80 to 90. That blue one is arts. The gray one is science. There's a lot of science students expecting those high incomes, relatively speaking, and not many art students expecting that level of income. So scaling is very, very important within this. Am I off topic here? So this is the picture I had initially. And I did grouping. Sometimes grouping doesn't work very well. Watch it. It sometimes comes up with errors. Just keep trying. It seems sometimes that you're highlighting the wrong part of the cell that you've picked. And so this was my grouping. That was my new and improved picture. And I took the gaps out. I gave mine a title. Generally, you should. That then I looked at comparisons across programs, and we just talked about those. And warned you the challenge to make sure you've got the scale right, that it's percentage of column total, percentage of the group. So if you're comparing groups, you generally want to know the percentage within a group that have some characteristic. And we'll be doing a lot of that today. And so if we're, let's flip from numeric data, because we've done histograms. I want to focus more on what I'd call categorical data and contingency tables. So if I've got two variables that are just categories, like program, arts, business, science, and then maybe a category about, are you worried about finding any job? We were just looking at that one. So the one I looked at initially, if I wanted to look at it now by program, how do they compare one to the other? And if I'm looking at a table, I'm going to want to clean it up and get it looking better first. So let's, both in terms of the sequencing of things like we did before, and taking out groups that don't belong and summarizing it. And so I'll do that in a minute. But if I look at this table of frequencies, is there a pattern here? Is there anything important? that, okay, we've got more science students than we do of the others. We also have more students that said unconcerned or very concerned than we did somewhat concerned or neutral. So the column totals differ, the row totals are different. How should I summarize this and scale it? And scaling it depends upon the question that you've got. What's top of mind? Why are you looking at this? What are you trying to compare? Uh, this one, there seems to be a natural type of comparison I might want to make. Um, is the level of concern among art students higher, lower, different from business students? And is that different from science students? So if I'm comparing arts to business to science, I'm going to be comparing columns. Okay? And I'm comparing different groups. So the groups you've got, you're going to scale it depending upon the size of the group and seeing what the pattern is within that. A minute ago, I looked at salaries. So I scaled it in terms of the categories I had where, whether or not you expected to earn 30 to 40 or 40 to 50 or 50 to 60. But if I'm comparing arts to business to science, I'm going to scale it in terms of how many art students, business students, science students, so that I understood those frequencies in a column appropriately. So with that show values choices, I can look at percentage of grand total, percentage of column total, or row total. And in this instance, I'm going to want the column total once again. And this is going to be my picture. And I could get rid of things. And I'm going to change formatting of this. Let me go back. So let's drag this guy out. I'm going to look at any job here. Okay. And let me look at my table first. So this one, I've taken the frequencies, already made them into percentages of the column. I'm going to get rid of the decimals. So number format. I don't like generally more than 2 digits to a number, 2 important digits, the ones that aren't zeros. And so that simplifies it. For the picture, it doesn't matter, okay, because you aren't paying too much attention to the scale and if it had decimals or not. I added a bit of a gap here. I'm going to add a bit more gap just so I can see this better. Let me just show you quickly what happens if I take the gap out. Okay. It's hard seeing this pattern because I'm looking at those that are not concerned, those are somewhat concerned, those are neutral, those clusters. I've got clusters along the bottom here, and the clusters are banging into each other because I've taken out gaps that are there. So I would generally recommend with these ones to actually if not to take gaps out, leave them in, or maybe even make them quite big. Maybe I'll make it 200%. So now I've got big separation between these 5 clusters of students that not concerned at all. The percentage of arts, business, science students that are not concerned at all looks very, very, very similar. In terms of somewhat concerned, that it's quite a lot of art students, not nearly as many science students. On the other extreme of the very concerned, heavier concentration in science students, less in arts and business. So one of the slides I had at the very beginning, we noted that there was a cluster of students that were somewhat concerned and a cluster of students that were very concerned and some people in the middle. Of the ones that are unconcerned, they seem to be more in arts. The ones that are very concerned seem to be more in science. Okay. Um, I'm not sure if we looked at it last week, but with the salary expectations, science students expected to earn a lot, business students or art students didn't, that those science students expect to earn a lot of money, but they're very concerned about finding a job. Art students don't expect to earn much, and they're not very concerned about finding a job. Maybe those two things sort of work together. Not sure. Are there other ways we could have shown that data? So I've got this now, and I've restored my gap so I could see the patterns clearer. Um, Still, the differences aren't enormous. I wouldn't read too much into this. My sample sizes are probably somewhat small. That I should actually check that. So before I go any further, I might want to go and look, just to back up, because I'd mentioned this at the end of last class, beware of small sample sizes. What if I just look and I take no calculation? Some of these are small, particularly among the science. Okay, they're not huge samples. I'd really like samples that are 100 or 200 or something, but I don't have that much data. They aren't super small, but except for science, they tend to get smaller than I'd like. Let me get back to what I had before. That what if I had asked for percentage of row total instead? Would that matter? Does it really matter within which I ask for? So I looked at arts, business, science. What if I change it, show values as percentage of row total? So before I look at my picture, I'm looking at, of those students that are not concerned at all, are they in arts, business, or science? Of those students that are very concerned, are they in arts, business, or science? Those that are very concerned, most likely to be in arts. Hold on. Uh, Before I was remarking that science students seem to be more likely to be very concerned. But now when I'm looking at those that are very concerned, I'm finding they're mostly art students. What's going on? My problem is the science numbers are small for every group because there are not a lot of science students. I had about 100 science students, and I had 200 to 300 art students. So I've got so many more art students than science students. These percentages will generally be bigger than those ones because of different sample sizes. If I look at my picture, what's it telling me? Well, the gray bars are low because I don't have science students. The blue bars or the orange ones are high because I've got lots of arts and business students. It's not telling me maybe what I wanted to see. It's showing me within those not concerned at all, if I add up these three columns, it'll add to 100%. If I look at very concerned, these three columns together add up to 100%. Each of these clusters adds to 100%. Okay, that's nice. But is that what I wanted? What was my question? And that's the important thing here. What's the question that you've got that you're trying to answer? And that if you're trying to um, compare groups, okay, that then you've got to cluster your things so that you are looking percentage of that group. And ideally, they're going to have to be in the right places. So this might be easier to show with a variable that's a little simpler than level of concern. Let me just look at gender. So let's throw this one out and get something that's easier to study. Okay, so here's a table of gender, and I'm going to get rid of blank here. Okay, so what's this one showing me? Here's a chart that across here it says females. Among females, because this is adding up to 100%, 49% are in arts, 35% in business, 16% in science. And among males, I have 29% in arts, 51% in business, 20% in science. So I might think that women are most likely to be studying arts, business, or males are most likely to be studying business. If I look at my chart, that's what it's showing. It's saying among the females, they're most likely to be in arts. Among the males, they're most likely to be in business. This cluster adds to 100%. This cluster adds to 100%. So I'm looking at program choice within each gender. Right? If I switch my percentage to column total, I'm saying within arts, among the art students, 3/4 of them are female, 1/4 of them are male. Within business, it's roughly 50-50 split between male and female. And if I'm looking at science, I'm looking at a split that's about 60% female, 41% male. Now, my chart gets a little trickier to understand here. This doesn't add to 100%, and this adds to 100%. Here's the 3/4 female being in in arts, and 1/4 of the art students being male. So of art students, 75% female, 25% male. Of business students, a little more than 50% female, a little less than 50% male. And among science students, it splits about 60 and 40. It's a little bit tricky interpreting the picture. The table is straightforward to understand, okay, the split. I don't think there's a problem of us reading horizontally or vertically. We seem to be adept in that. But this picture doesn't seem to look right. And it's because what Excel does is it grabs whatever the rows are as being the categories on the horizontal. So since female and male are my horizontal categories, it's put them there. But if I want to look at this table is looking within art students, what's the split? Within business students, what's the split? And science students with the split. It's not doing it the right way. So to do that properly, I'd need to put program here, gender up here, but I now want to do a comparison within arts, male, female. So I then end up having to change this as well to show values as percentage of row total again. Now look at my picture. So here's a picture that says art students split at about 3-to-1 of female versus male. Business students, it's almost an even split between female and male. Science students, it's more 60% female and more 40% male. So the grouping that you've got is the one you're going to want. There are two things here in terms of a picture and in terms of the a table or any type of summary. You generally, if you're comparing groups, then it's percentage of the group total, whether the group is in a row or in a column. In your picture, you generally want those groups to be on the horizontal axis, the clusters that are here. So it's best to put those groups you want to compare actually on the horizontal axis, or on the be your rows, and then get percentage of row total. You got to be careful, and it has to do what's the question. Do you want to see what the pattern is of females across programs, or the pattern of gender within each program? This is the gender pattern within each program, whereas the one we had previously is the program pattern. within each gender. You've got to be careful how you're structuring it around. We're going to look at this particular issue in a lot of detail in those percentages, because those percentages can be perceived as probabilities. And we need a good understanding of a lot of probabilities. And these are called conditional probabilities. And we're going to address that issue several weeks from now. But for now, we're just looking at summaries, making pictures. So I just went through and did some of these the different ways and trying to figure out what it is that you're trying to show. That and don't give yourself too much detail. So it's things like among females, what percentage are studying arts, or you're asking among art students, what percentage are female? Those are different questions, and we're going to organize it different ways around. That, okay, I've done that. Okay, just some cautions about this one. You'll notice that for each program, arts, business, and science, there were more females than males. That if I was to generalize and talk about students at St. Mary's altogether, is that correct? And at the time of this survey, no, it wasn't. At the time of the survey, if I took arts, business, science students, lumped them all together, it was fairly close to being 50% male, 50% female. That in arts, it was probably 80% female. Business was about 50-50, and science, I can't remember how the split went. What we saw in this data set, it's based on a survey, so it's an observational study. We only had data on the students that chose to reply to the survey. And very frequently in surveys, we find that females are more likely to participate in a survey than males are. We see other patterns by income group and by age, by a variety of things, different patterns in response rates to surveys. So that the pattern we may be seeing is not a pattern of students in a program or within the university, but a pattern of responses and the way people respond. In some instances, we know what the correct pattern should be. With this data, we should have known what it would be, because we could look in Banner and find out how many art students, business students, science students, males, females, all of that type of thing, and had it exactly. And so it's not uncommon in big studies where they do have some benchmark data to actually weight the data. And in this one, they would have given a smaller weight to female responses because there's so many, and a bigger weight to male responses because there's so few. And they'd adjust things. And they'd be using those weights when they're looking at responses to other questions for which we don't have benchmarks. So looking at level of concern about finding a job between males and females, we would be reducing the responses for females to that question and increasing the value of responses for males and making some adjustments. With an observational study, there's going to be distortions in your results based upon who responds and who doesn't, who participates, who doesn't. And that mix of participation may not reflect the general population. So that you do have to make, if you've got other data, you would make adjustments to it. In a lot of studies, we don't have other data, so we don't know how to make adjustments. We just have to be cautious. So, but think about that in observational studies as to who participates and who doesn't. And are the differences you're seeing because of just who they are rather than other types of reasons? We can also make this thing more complicated if we want to. Let me go back to my Excel here. I could go and drag gender over here, and I could look at art, business, and science, and within that, males and females, or I could put it the other way up and look at females and males, and within that, arts, business, science, and drag in another variable. I could look at the getting a job in your major, drag that into columns, and getting a big messy table here, and big messy picture. This is arts females, business females, science females, art, business, science females. I've got them as the male block or female block on one side, male block on the other side. If I switch these guys, oh, here I can switch them here. If I switch this, you'll see it's arts, business, science, and within that, male, female, and so on across. The percentages I've got here, God, I've got many, many, many bars, lots of pretty colors. Some of these ones I don't need. I could take some of them out. The not sure and the not applicable. That these ones aren't sequenced properly. Notice, they're alphabetical, so I might have to go back to my table and sequence them better. That move this one up, move, or sorry, down. I guess that's down. And I think this is unconcerned. I'll move this one other way. There. Now it goes from not concerned, somewhat unconcerned, neutral, and so on. My picture is very, very, very busy, nonetheless, again. And what I'm looking at in terms of percentages, I'll need to move that out of the way, is percentage of each of these subgroups that fit that sort of thing. So I'm looking at the pattern, and that may not be the sort of the of responses from not concerned, somewhat unconcerned, neutral, somewhat concerned, very concerned. And so, some I'm getting this sort of U shape, but female art students don't seem to be particularly concerned at all. That it varies across these different sorts of groups. You may want to cluster it, trying to make it even simpler. Generally, to tidy things up, I've got to do that in the table, and it carries over. I could go and take these two, and whoops, and can I group them? And I'm going to call this group 1, and it's going to be my unconcerned. Oop. And collapse that guy. And I'm going to collapse this one, and this one, and I'm going to take this one and that one. So I'm trying to make these ones, and these are the ones that are concerned. If I look at my chart now, I'm just trying to make it somewhat similar or simpler to look at. So here's this pattern I've got of unconcerned versus concerned, unconcerned versus concerned, and seeing are there any patterns that I'm seeing between these two groups. And as I said, the female art students, no big deal about finding a job, maybe bigger differences among science students or maybe among male business students. Female business students don't seem to be overly concerned. There's a lot of detail. So when I'm getting into many groups, that this one that I've just made smaller, I got it down to having, here's 18 actually different categories, different boxes in my table, or 18 different bars in my chart. That's a lot to compare. And before I started collapsing it, there were more than that. There was about 30 different boxes to compare. It's really, really, really busy. When you've got You can compare three things at once, but it's hard to do. It becomes a very busy chart, very busy table that you've got there. Um, you can rearrange it, try to simplify it, reorder things. Makes it harder to figure out what's the question that you've got. What are you really trying to compare here? And it may be that it's it's not going to work for you. When we've got to make comparisons, comparing more than two things is generally very, very difficult to do. And if I went and looked at the frequency counts of here, I'd probably find there are very few values in some of the boxes. So many of the boxes are suspect. Collapsing them like I did might help reduce that, but still, it's not a lot. I would be cautious that um, the the key question, because we can make these charts very, very easily. It's not hard for us to do. It's what is the question you're trying to figure out. Spend more time thinking about the question. What's the question? And what does the answer mean to you? How would you use that answer? And if you can't quite figure that out, then it's probably the wrong question to ask, or it's one you shouldn't be asking at all. That figuring out what your objectives are along the way. As I said, as you drill down, sample sizes get tiny, and I think a lot of your analysis is probably suspect. To give you an idea of what I mean by suspect, the percentages, just like averages, are estimates. And if you collected another data set, you're going to get slightly different numbers. How different? They can actually be quite different. With percentages, um, that the we don't get accurate measures unless we've got fairly large samples. If you recall, when in understanding empirical rule, don't be surprised if you're off by one standard error, and sometimes you can be off by two. Most of the time, you're not off by more than two. So maybe as a rule of thumb, think in terms of two standard errors. How big a difference does it have to be more than two standard errors away? Two standard errors, if I've got only a sample of 50, being off by twice 7%, being off by 14%, happens all the time. So there's not much difference between 50% and 60%, or almost 65%. Those are really big differences in terms of numbers. But when I got a sample of only 50, I can't measure that accurately. When I've got a sample of only 12, my estimates are garbage. If I had a sample of 1,000, most major opinion polls are 400 to 1,000 people. So if it was a sample of only 400, don't be surprised if your estimates are off by about 5 percentage points. If you got up to 1,000, might be off by 3 percentage points. That it's hard to measure things really to within 1 or 2 percentage points. You just don't get. So if you were told that there was a survey done before Christmas, if an election was held tomorrow, what's the chance that or what percentage of people would vote for the Liberal Party? And if it was before Christmas, if the number was 44% and the percentage today was 42%, I'd say it's not changed. Support hasn't gone down necessarily. 2 percentage points, I wouldn't have been surprised if it had been 4 percentage points change just by chance. And if that was last week's survey, it was 42, this week's survey might well be 46. We get swings like that all the time of a couple percentage points. Don't read too much into it. So again, I go back to the issue when you're looking for patterns, if the differences are relatively small, 2, 4, 5, maybe even 10%, don't fuss about it. If the difference is more than 10%, then that's a big deal. You're going to start paying attention when it gets more than 5%, and you're going to focus much more when it gets above 10%. Those are big, big differences, big patterns. You'll get into, when you take statistics, they'll look at this issue in a lot more detail. So to recap, pivot tables, I can summarize all kinds of data, frequency data, and even numeric data in terms of averages or patterns for numeric data with histograms. Any which way I summarize it, though, scale is going to be critical. And generally, scale I'm looking at is percentages. Percentage overall, percentage of a row, percentage of a total. When you're displaying a table, get rid of unnecessary detail of rows or columns that really don't belong, of digits that you don't need. If the rows or the columns have an order that matters, put them in order. That may be most important to least important, or least to most. Or if it's an ordinal variable, like very satisfied to very dissatisfied, put them in order. Charts generally are more effective than tables are. People respond, you get a stronger response to a picture than you will to a table. That the picture also helps you identify the big differences. In a table, people look at the numbers and say, oh, 23, 21. With a picture, you don't pay attention to those little things. But it is important the way you orient your table, the way you group things along the axes, percentage of row, percentage of column. Are you summarizing it by rows, by columns? And getting into 3 variables is probably too much work. It's going to be too confusing. Do it only if you really, really have to. Beware of small samples. Your estimates are not going to be reliable. Next class, we're going to start in Chapter 5, moving from summarizing data to making models and predicting. And Chapter 5 is the beginning of the transition. It's still going to be summarizing, and we're going to look at 2 last ways of summarizing things with charts, generally for numeric variables, different types of charts for summarizing things, other than a histogram like we've done before. And they're generally charts to summarize numeric variables and looking for a pattern. As we move into Chapter 6, we're going to start taking the patterns and building models around that to make predictions. And as we go beyond Chapter 6, we're going to be focusing much more in Chapters 6, 7, 8, 9 on building models and understanding these models. But Chapter 5 is one that's somewhat interesting in that transition, and we'll be looking at probably one of the few things, few tools that I'll ask you to do the work by hand, and you don't even need a calculator to be able to do. It's a manual. The calculations are hopefully sufficiently simple that you don't need a calculator. At least if you can do a little bit of mental arithmetic, you won't need one. But we'll leave that till later. And that's where we end today. So again, go over your assignment, see what you did right or wrong. If you did poorly, you can revise and resubmit. You can look at the answers first. Just don't copy the answers into your new solution. Go through the Excel tasks yourself to get those screenshots. And with the ones where it's explanation, come up with the explanation in your own words. Don't use mine. Mine will sort of jump out to me. And email it to me. And we'll see if we can't get you some points back. So we'll leave it there. You guys take care. And you'll see me again on Wednesday. Bye now.